Hello, folks. My name is Igor Wojda, and I work as an Android developer advocate at Vonage. We make communications API, so if your application is to send SMS message, WhatsApp message, make an audio call or video call, or send PIN verification code, you get the idea. That's us. So today we will be talking about application architecture. To be specific, this will be green architecture. Before going there, you are probably aware that there are multiple approaches to application design, multiple approaches to architectures. So the main question that we should ask ourselves, like, why do we need good application architecture? What are the benefits of actually having one? So this is quite complex question, and we can say we want a code that is easier to understand, easier to maintain, or like easier to test. But from purely developer perspective, we want to avoid classes like that. We want to avoid God classes that have few hundred lines of code because they are quite difficult to change and maintain. On top of that, we developed software in a world where everything is changing. So nothing stays the same. It may be customer requirements will change. New version of library will be released, or you want to replace some library. New version of Android will introduce some constraints or change the way we do things. Maybe new device will add some capability, like fingerprint, for example. Some time ago, we need to deal with languages, right? A few years ago, we had this transition from Java to Kotlin. It was smooth, but still there is something to consider. On top of that, Google also introduces new tools and things. So recent Jetpack, like introduction to Jetpack, had a major impact on the way how we develop Android application. And in this world, we don't work alone, right? We as a dev need to understand the code that is written by other devs. So if you work on one view model and then you open another one, you should instantly know what's going under. So our goal here, like in a good architecture, is to have single responsibility classes that are properly decoupled. That those small classes that have single responsibility, but they also have to be properly connected as well. So sometimes pieces make perfect sense in isolation, but when we connect them together, they fail. And this is a perfect example. So nowadays, many developers follow what I would call MVX architecture in Android applications. So V, of course, stands for a view, which is presentation layer. Then we have X, which is some kind of controller for a view. So it may be controller, presenter, view model, or intent. And from this, the names of those patterns arise. Of course, nowadays we would not use MVC. MVP is also going away. So MVVM is a way recommended by Google, but also MVI is like this more reactive approach. So this is something to consider. Also, probably it will go out soon as well. So MVX. So then we have model, and problem with model is that it's usually not properly defined. When you think about model in this architecture, it's like responsible for data retrieval format, for caching, data persistence on local device, transforming, and business logic. So in reality, this is not really an architecture. It's more like most like presentation layer pattern with big model in a backend, in a kind of backend. So in practice, models usually look like this bunch of coupled classes where it's hard to say what's going on. So looking at high level, we can improve this architectures a little bit. So we could split our model into repository that has multiple data sources. So one data source may be network, another one would be a local database. So those components, most of those MVX, let's say, components work well with clean architecture. So we can see how we can improve it further. So let's leave aside MVX for now and look at the clean architecture approach. So clean architecture requires us to think about our applications in different way. So we would have a group of let's say use cases or user stories, maybe not user stories, but user stories, but they may be also from system perspective story that describe what application does. So let's make an audio call, receive SMS message, maybe save user profile. This would be like a story, and group of plugins that allows us to fulfill those stories. So it may be like network libraries that give us network capability, or maybe some kind of analytics panel that allows us to track users. So let's look at the main idea behind clean architecture, which is the business logic. And this is something that in a clean architecture is in the center of our application. So it has no dependencies on the outside world. It's kind of independent from libraries, frameworks, independent from UI and different data sources or libraries that are used to work with those data sources. So we basically use all those framework and everything around business logic, kind of like a tool to support this business logic. So I know this is a bit abstract, so let's take a closer look how this can be achieved. So to understand clean architecture, we need to take a closer look at something that is called a dependency rule. So in the center of our application, we have entities that they basically are represented by, let's say, data models. Then we would have some kind of use cases that represent business logic. So let's say, get me all the users. This would be example of business logic. Then we would have in outer layer, we would have view models that are responsible for controlling our views and repositories as well. And in the last circle, we would have UI components that are closer to user and data sources that are closer to network. We'll look in the more details soon in those components. So the important thing is that the business logic, which I would say use cases and entities inside, like every item within the circle knows nothing about outer circle. So those dependencies kind of flow outwards. So dependency rule, this is the dependency rule basically. So we need to distinguish this from data flow, which is a little bit different. So when user interact with our application, usually it goes from UI to network through different layers and response go back. So let's look how we can implement this in Android application. So we would split different circles into different layers of our application. So we may have, in this example, we'll go with 3 layers: presentation, domain, and data. However, in real life application, especially larger one, you may have a little bit more layers. So vertical lines represents boundaries between those layers. So as I said, like domain layer should be independent from anything else, from like basically all the libraries and all the frameworks that we use. Of course, it will have some dependencies like Kotlin standard library, because we just have to use it. Maybe dependency injection library will be there as well. But it's important to know that like ideally it should not have dependency on even on the Android framework. But from practical perspective, it will probably have one. And here is our data flow and our dependency rule again. So ideally, in a clean architecture, we have multiple components. So in presentation layer, we would have a view that is responsible for user interactions, view models that control this view. In domain, we would have use cases that contain business logic and entities. Data layer would be the repository and multiple data sources, or maybe single if you have simple application. What is important here that those are small building blocks that they're well decoupled with single responsibilities. So some of them are the components, from MV, MVVM, or MVX. So those, and of course, dependency rules applies here as well. But the question is, how would we make our use cases independent from the repository? So our use case needs to access the data from the repository, but it's defined in domain layer, and we want to keep it independent from data layer. So the answer for this is dependency inversion, where in 3 simple steps we can reverse dependencies between classes. So first step would be to define interface within domain layer, then create class in data layer that implements this repository, and then we would inject this repository into our use case. So this allows us to use repository within the use case, but make it independent, make use case independent from the repository. So those arrows basically represents the direction of the dependencies between our layers, because as I said before, like domain layer is in the center of our dependency rule ring. So it cannot depend on any other layers, which means that it doesn't know that anything exists outside of it. So it's unaware about the views, view models, repositories, and especially data sources. So before moving further, let's look at an example where we develop our application, we extend it, and our data models goes completely wrong. So we define simple model for our application that holds basic information about the user, right? ID, first name, last name, and date of birth, because those are the data we want to store within our application. Then after some time, we decided we want to download this model from network. So we would add some JSON annotations to this model, because this allows JSON library to parse certain fields from network data, like from XML into object of our application. Then after a while, we get a requirement from our project owner that we want to store some data, cache some data locally. So we would add more annotations. This time we want to use room, so we would add annotations for room table and some information about the columns. Then after a while, we decide that we want to access this data in a little bit different way for a view. So we would add some synthetic properties, derived properties, to make our life easier and have better API for this class. So by looking at this like natural evolution, each step was logical, but at the end we created a GAD model. And the problem with this approach is that we tightly couple UI with our derived properties, network, and database model. So it will be quite challenging to maintain application like this, because imagine that network data will change. Maybe we will remove some field or rename some field or maybe add one, and then this may crash some application, because data stored in the local database doesn't really reflect the model anymore, and because application rollout or update application to all the users will take some time. So we need to have this like intermediate phase where some of our users will have new application that will download data from network and everything will be fine. But some of our users will have old application and they may download some data from network that will break it and crash our app. So solution for this is define multiple data models for different data sources and data representations. So we'll have one data model for network, one for our room local database, one for our domain, and maybe one for presentation. Usually, presentation can be skipped because sometimes it's not practical to have it, but it can always be added later if it's needed. So to translate those models, we would need some kind of mappers. So I will get back to those mappers in a minute. For now, let's take a look at models. So instead of having this big GAD model, we would have one model for network that contains JSON annotations. This is basically Kotlin data class. Of course, it could be Java Pojo class, but Kotlin is just much more convenient. Another model that is for our room or database data. Another model that we use in our domain layer that represents our user, and another model for presentation layer. So basically, instead of one GAD big class, we would split this model into multiple classes. So for some data, it doesn't really matter that much. So let's say you want to represent username. So this would be a string, basically within every model. So this data is exactly the same. But for some data types, this creates a massive difference. So let's consider the example where we want to download, we loading the date from our network. And in our network, this date is represented as ISO 8601 format, which is basically a string that contains hard-coded date with the time zone. Then maybe we want to store this date in our local database as unique timestamp, which is basically an integer. Then in our domain model, we may want to store this date as datetime object, mainly because it's much easier to operate on such object than on simple string. So operations like comparing two dates, is one date larger than the other, or calculating difference between dates became much easier, especially with all those years that may have more, or like 29th of February, or some edge cases like non-existing months or even years. Well, this is longer story. So let's get back to our mappers for a while. So we have those mappers that translate our data models. So looking at very high level, our mapper is a class or a method that takes model of one type and returns the model of another type. So in our case, it may take network model and convert it to domain model. So let's take a closer look at the clean architecture implementation of at least some of the components. So there are multiple ways to define those things. So mapper can be defined as interface, simple generic interface with two generic types. Like we take one type and return another. So practical implementation would look like this. Skipping aside like class definition and method definition, would have method that accepts one parameter, which is first model, and return other model. So here ID, first name and last name, we just basically copy them, but with the birth date we convert it to different data type that is more convenient to us. Of course, we can implement mappers as a Kotlin extensions. This is a nice shortcut that will allow us to easier convert this data within repository. It's a little bit difficult to test, however, so we always need to consider different trade-offs. Then we have views in our application. As usual, those are activities or fragments nowadays. And with views, we try to keep them simple, maybe if statement, maybe simple loop, but like nothing else. We try to keep them dummy because views are difficult and expensive to test. So the less things we have within the view, the better for us. With the view models, we would have class that basically exposes some functions that view can call. So let's look at get users example. So for getting data from our network, we need some kind of asynchronous solution. So it can be Eric's Java or Kotlin coroutine, like in this case. And view model provided by Jetpack gives us view model scope, which means we don't have to inject coroutine scope anymore. So we'll run this use case, which basically will give us result, success or error, and based on that we will pass this data to the view. So display list of users, for example, or display error to the user. Then we will have a use case. So use case, again, it's class that contains business logic. So in this case, we need a repository to get this data from. So this user repository is actually the interface that is defined in this domain layer. So we'll have simple function that will get our users. And of course, because we want to perform some kind of more business logic than just getting the users, we want to filter them by certain criteria, like here, we want to only return adults. We will put this business logic within here. So the question that may arise, why would we need use cases? Like, why cannot we define a perfect API for us, for example, that will give us the data we need? And the answer is that we sometimes don't have a control over API. So it may be third-party API that we cannot change. So use case would be usually the place where we would format the data in the way we want. It might be a repository, depends whatever or not this is closer to business logic or data or just data kind of filtering. Another case may be maybe we want to aggregate data from multiple data source. So like get adults from one API and get adults from another. Then we would put this in business logic. However, if you want to aggregate data from like network and database, probably this will go to repository as well. So entities are next on our list. So they are basically, as you've seen, they are simple data classes that just describes the model, and abstractions are interfaces that will be implemented by repositories within data layer. So looking at the repository, we would have repository that uses some kind of data sources. So this is a simplified example that only uses retrofit service to retrieve the data. So again, this is implementation within data layer, and user interface is defined within domain. User repository interface is defined in domain. So simple method that basically returns the data. But of course, we have one important step, because data layer doesn't know about domain layer. We need to perform some kind of mapping. So we map this data model into our domain model. So there are multiple ways to implement layers within those clean architecture layers, and So first approach would be to define them as a layers, as a packages within single Android module. The downside of this approach is that we don't really control those dependencies between layers, so we could use things that are defined in data representation within domain layer by accident usually. So we are not protected at all, and also this doesn't scale well because we put everything within single module. Another approach would be use separate modules, separate Gradle modules, or Gradle subprojects and Android Studio modules as a layers. So we would have three: one for data, one for domain, one for presentation. And this looks better because this allows us to guard. We can define dependencies in a way where domain doesn't depend on anything. So in this case, we would have the way to protect us from making mistake from using, let's say, class or function that is defined within data layer inside the domain. However, this solution doesn't really scale well without many features, because we would have to jump between different modules when implementing one feature. So the third approach, which I would recommend, is just use feature modules. So each feature module has 3 layers. Unfortunately, we lose this ability to guard us between guard us from using wrong dependencies. But this can be easily achieved by some custom lint rules or some other frameworks like ArcUnit. So we will have a feature where each feature has defined its own set of layers. So benefit of this approach is that everything that relates to one feature is in one module. We can also use Android dynamic delivery. And on top of that, we could parallelize our work within the team. So let's say one squad or one part of the team may work on certain feature, while other squads or team or sub teams may work on another. So this allows us to develop this application in parallel and also keep those those feature modules kind of all the logic regarding related to the feature is contained within single module. So let's look at the data flow within our application. So let's assume user clicks the button on the view and say get list of users. So user clicks this button, we pass this control to our view model. View model pass this control to executes a method on the use case. Then use case retrieve the data from the repository. Repository will check if it has locally cached data. Of course, if we have it, we may not have like local cache at all. And if answer is no, repository will retrieve data from network. Then this data will be cached in our local database, mapped via mapper to the use case. And use case will return this response error success to our view model, which will update the view. So the question that arises, like why we are doing all of this, why we define so many layers and so many modules and so many pieces. And the reason is that because our layers are properly separated, this allows us to make our domain and business logic independent from external changes, mostly libraries and frameworks. So imagine we want to change our tab layout to the bottom view that Google introduced some time ago. And we can make this change without affecting our view model, business logic, and everything in data layer. The same, we can change grid view to the recycler view and will not affect any other part of the application. Even more, imagine we used SQLite, but now we want to switch to Jetpack Room. And we would do this change, ideally without affecting any business logic and any presentation layer. We may replace Volley to the retrofit. But also we could add things like, let's say we track our users' analytics using Firebase, and then we want to add another tracking service like Mixpanel. So it's quite easy to add new components or swap existing ones without affecting any other layers of our application. Important thing to mention here is that nowadays we have a trend for those multi-platform applications. So technically, it would be possible to design application in a way where your business logic would be shared across multiple platforms like Android, iOS, maybe even your backend or local Raspberry Pi, which gives us a lot of flexibility and consistency across platforms. So testing is also easy because we can basically only inject things that we need in every of the components. So for example, for repository, we would inject data sources and of course the mapper. For use cases, we would inject required repositories, and for view models, we would inject use cases and maybe mock of the mapper, and for the view, mock of the view. So of course, benefit of using mocks is that, for example, for repository, we may use in-memory database, which is much faster, or some kind of local server that returns us as the data instead of asking network, which will speed up our tests and make them more repeatable, less flaky or non-flaky at all. And of course, we can test our mappers as well. So with all those classes and pieces, there are a few things to consider. So of course, there are cons and pros of this approach, right? So let's start with cons. So we are writing much more code, and this is like number one con of the clean architecture. So for smaller projects, it may be overkill, and there are And there are multiple implementations of clean architecture, like especially for the Android. So you need, and they show you how to do things, but they not necessarily explain like the design's decision behind it. So sometimes we may not understand the trade-offs. However, there are multiple processes using this architecture. So we would have like adding new library will not affect our application. For project with longer life cycle, larger project that will grow, this architecture scales very well. It's amazing for bigger teams or parallelizing the work. It's very easy to maintain and understand it. So if we keep our classes consistent, if one team or member or developers work on one feature, he will understand another quite easily. And it's easy to test because we have those very small pieces. And usually, from practical point, there are no merge conflicts. And even if they are, usually they are tiny and quite easy to resolve. So I prepared a few links for you so you can read more about the clean architecture, which was introduced by Uncle Bob. My article about multiple ways of defining layers here, as well as few Android projects that implement clean architecture. First one is mine. I got a few thousand stars on GitHub by accident, but I tried to explain everything really well just to give you the idea how the things should be done using modern approach, as well as few talks that I encourage you to check out. So this is it on from my side. So slides will be available on Twitter. Please follow me. Any questions? Okay. So we have a question. Doesn't the fact that you had the repository as constructor param for the use case break the dependency rule? So actually we don't have a repository there as a parameter. So it's an interface that's implementing domain layer, and the actual implementation in the repository is in data. So we don't break this this dependency because we use dependency inversion. Another question. Can you show us? Oops. Can you show us again where the mapping sits for each layer? Okay, I'm not sure if I can show you this, but basically the idea is that let's say domain layer is within the center of our silk. So if we have so like here's a domain layer, and let's say here we data layer. So if data layer knows about domain, the mapping have to be in data layer so that the proper data format is passed to domain. The same on the other side when we have presentation layer and we want to map some data. We need to do it on presentation layer because the domain layer doesn't really know about presentation, so it could not perform the mapping. So always the outer layers are performing mappings for inner. Okay, so one of the things about so much separation layers and navigating the code base on where things happen. Do you have any recommendation to grab this? So I would encourage you to check my personal Android Showcase project. So at the beginning, it may be a little bit overwhelming, but if you start working on clean architecture, it's quite easy to get the idea where things are. And that's why I like feature modules, because they kind of contain everything within single Android Studio module. So it's quite easy to navigate between all the layers within single feature. Okay, next question. At this architecture, which test approach do you prefer for the UI, instrumentation and integration test? Testing is complicated subject. Like there are so many ways to test our Android applications and so many testing approaches. So I would say basically use whatever work. It doesn't really matter. Like for clean architecture, probably you would use similar testing approach as for MVVM or MVP architectures. Okay, another question. So what is your approach to error handling within the mappers? Example, AP does not return a birthday as expected. So ideally, we want, so like depends. So I would say for a developer, like developer version of the application, I would probably try to crash a little bit more than for the release, just to have instant feedback. But in general, like you would have to you would have to expose as well some kind of data type if you want to handle errors that contains like two, like Kotlin sealed classes with two child classes like error and success, and maybe even third one loading, and just pass it through all the application. This is unfortunately a little bit of pain, but this is for like true for all the approaches in Android if you want to do it right. Where do you handle navigation, in which layer? So navigation is handled within presentation layer. So Android navigation component, the way it's designed, it handles navigation within fragment, which is the view. But personally, I don't like this approach because I like to keep my views simple, and I don't think navigation is really responsibility for a view. It's kind of between view and view controller, which is view model nowadays. But what I personally do, I have some kind of navigation manager class that I inject to my view model. So user clicks the button, and then we call method on the view model, and we navigate from there. Okay, next one. Oh my God, you have so many questions. Nice. So why bother having a repository interface? Why not just inject the repository implementation? So the reason it's just easy to inject mock of the implementation. So the main reason for having interface is to keep the layer separation. So interface for the repository allows us to have our domain layer independent from data layer in this case. Which means that if we change something in data layer, it should not affect business layer at all. Next question. Do you set the parameters of the API response models as nullable or not? If nullable, where does the mapping to non-null parameters happens? Good question. Personally, I would keep them as nullable to avoid crashes, especially when we update our API, and then I would try to map them to non-nullable with my mapper in the repository. So this way I could give some reasonable default values, because usually like if API would stay the same all the time, I would just keep them as non-nullable. If I know the item property is there, it would be there. But because API changes and evolve over time, there is a chance that we have some old client that may not understand certain property after it was added or removed. So I would keep them probably nullable, unless I'm absolutely sure that they will never be null. Are use cases necessary, useful when we control the server and the models it return? So approach with use cases is the ideal one, but also I would say for simplicity you could kind of skip them. So it's just good to think like how your application should ideally look, because at the beginning when you develop application, so in my case it was most of the use cases just called repository method and didn't really do any complex business logic or any complex logic at all. So we used the shortcut where we basically injected repositories into vmodel, but keeping this in mind that in the future like use cases should be ideal there. So you try to find this balance between, not introduce like too much artificial overhead just for sake of doing this, but at the same time like have this long-term direction and see how your application architecture will evolve. Oh, great presentation. Thanks. I'm glad you like it. Follow me on Twitter. And I think this is the last question. Do you think the repository layer is really needed? Sometimes I think it's just proxying calls to make data sources. I would say like this. If you have one data source like network, maybe you could think about skipping it. But again, if you wanna make things right, especially for bigger teams and more data sources, I think we should keep it. There are no like 100% correct answers. There's always a trade-off. There is always a pro and con of doing something. So the most important thing in developing application architecture is to be consistent. Like whatever you decide to do, just like do it everywhere within the project the same way. MVVM or MVI. So I'm going with MVVM for now. No, actually, I'm going with MVI in my project. So I like both. Currently, I would say I like MVVI more, because MVVM became a little bit complex when you pass a lot of data to the stream. Like we are not sure should we expose one live data stream or multiple. So and with MVVI it's easier to reproduce the state of the view. But also Google is pushing for more kind of reactive approach when building our views with how it's called composable. There is this new thing from Google. So at the end, I think we'll kind of end up with variation of MVI. Okay, next question. Do you think that if I use case dependent on another one, the dependency is broken? No, it's not broken because use cases are defined within domain layers, so it's absolutely fine that one use case is composed of other use cases. You mentioned you liked feature modules. Would you have one monolithic local data source or one per each feature module? Definitely one per each feature module. It's just easier to maintain those things if they are separate, even if this sometimes means duplicating a little bit of data. But also it's usually what happens when the application will have some kind of base feature module where we would share some classes between our feature modules in our application. So this is it. So, another question. So for a server-driven UI approach, do you think it's worth having all layers? Um, to be completely honest, I haven't worked with application like that. The one I heard about was just basically it had just Android web view, and those views were kind of generated within this web view. So then you don't basically need many layers. Or minimal amount. Okay, so I think this was the last question. So again, thank you for your time. I hope you enjoyed my talk, and I hope we'll stay in touch and have a nice day. I think yes, have a nice day.